Good afternoon or good morning if you're on the west side of the country. So you're very welcome to Truck Weight Analysis, helping distributors to sell. As many of you know, TruckScience partnered with NTA in 2019 to provide a next level solution for calculating axle weights. We extend a special welcome to NTA members joining us today. My name is Sarika O'Grady and I'm Chief Marketing Officer at TruckScience. Upfitters who perform weight studies can provide valuable information to their prospects and customers. Typically, a weight study will calculate axle weights, vertical center of gravity, and maximum payload. Furthermore, it should verify that the upfit will comply with the chassis manufacturer's limits as well as DOT regulations. Having appropriate tools backed by relevant data allows this information to be calculated and presented in a timely manner. Body and equipment manufacturers can support direct sales teams and distributors by providing them with some of the data they need to perform these weight studies quickly and easily. So in this webinar, I'm going to show you how body and equipment companies can make their product specs available either to trusted distributors only or to a wider audience. The webinar will include a live demo of the TruckScience Axle Weight Calculator using a Class 3 vehicle. So let's talk for a moment about why we should plan a truck layout. As you know, truck design is all about competing priorities. We're going to briefly look at some of the things that upfitters, fleets, and end users are trying to achieve, and some of the constraints that must be taken into consideration when designing great trucks. Performing weight, center of gravity, and payload analysis before embarking on a truck build helps you to achieve higher maximum payload, better vehicle stability, and optimal utilization of axle capacities. It should also contribute to decreasing capital cost and fuel consumption through right-sizing the chassis, minimizing unforeseen issues that could result in costly rework, maintenance, and warranty issues, and not to mention avoiding fines. But as we know, designers are constrained, firstly, by the rules of the DOTs in the states and/or provinces in which the vehicle will be operated. For example, final stage manufacturers are required to certify that the vehicle, as completed, complies with all applicable Federal Motor Vehicle Safety Standards, or FMVSS, and emission requirements. Secondly, the capabilities of the chassis, for example, the gross axle weight ratings and gross vehicle weight rating. And lastly, we need to take into consideration the operating conditions, for example, the space available for the vehicle to turn. No doubt you could add to this list. Many of you attending today, and some of you I spotted in the waiting room before we started, have been using TruckScience for years. Others are seeing it for the first time today. So the pace may be a little slow or a little fast at times, but please don't worry if you'd like to schedule a personal demo at another time to walk through an example that's relevant to what you would do in your company. We will gladly set that up for you. My challenge will be to keep the balance, if you'll pardon the pun, between giving first-timers enough information to know what's going on and without boring, hopefully, those of you who are proficient in the use of the tool. Just going to talk for a moment about what TruckScience is and what it is not. At its heart, the Axle Weight Calculator is a software tool for speccing the best truck for the job. And this is at the concept stage. It's not a complex engineering tool. It doesn't perform crane stability, frame stress, cornering, or braking calculations. And it's not a CAD tool. In fact, we say it's a pre-CAD tool. The tool brings chassis specs, bodies, and equipment specs and legislation together. So you can calculate axle weight distribution, dimensions, center of gravity, and maximum payload, and ensure you comply with chassis manufacturer and DOT regulation limits, including bridge formula. We're going to jump into a quick demo now, and I'm going to show you how to configure a vehicle with custom drawings how to calculate axle weights, maximum payload, center of gravity, and overall dimensions, how to confirm that your configuration complies with your chosen regulations, and how to generate a report. Let me just share my other screen. Okay, so the first thing you see here is obviously a number of brands, and this represents the chassis library in the tool. You can filter this library on manufacturer. So for instance, Ford, Super Duty, 4x4, and you'll see there are lots and lots of chassis specs in there. So we can further filter this list, like for instance, the F350, the regular cab, diesel, and dual rear wheels. Just going to sort the spec date here on 2023 and open this Ford F350 with the 169-inch wheelbase. A little bit of orientation here to get us started. All of the inputs will go in on the left-hand side. So that's about your vehicle, body, equipment, and payload. We've got a compliance dashboard beneath the cab here. And it will show you if you're complying with manufacturer limits. And those are obviously the Ford's own weights and dimensions limits and regulations, which in this case today is Illinois state roads. Lastly, on the dashboard, we have organization standards. And these should turn green when we actually build up the vehicle. But these are ranges of values that you can define based on your own personal or company best practices. So I've just defined one for now, this gross weight on the front of the vehicle as a percentage. I have stipulated that that should be between 10 and 50%. You can obviously set your own limits for those. And there are many other values that you can set up here as your own organization standards. For instance, you might have a limit on the utilization of the gross vehicle weight rating. We can get into more of those in the questions if there's any need to do that. Next, we have the weights summary or weights table. It provides a detailed breakdown of axle weight distribution. So you'll see the top rows in this table represent an itemized list of the various components, including the chassis, and how their weight is distributed over front and rear axles. In this case, for now, there's just chassis and crew. These are added together to get total unladen weight. And if we skip a few rows to the permissible weights are derived from the most binding of the structural and street legal constraints. That is, the lesser of the manufacturer ratings and state regulations. In this case, in Illinois, the regulation limit on the front axle is 20,000 pounds. The gross axle weight rating, as specified by Ford, is just 5,600. So the permissible is the lesser of the two of those at 5,600. When we add a body in a moment, the total unladen weight will be compared to the permissible weights to calculate the maximum achievable payload. And I will show you when this happens, but the payload will be added back to the unladen weight to make up the gross weight, which is highlighted in green. Lastly, the gross weight will be compared to the permissible weights to calculate unused capacity, or what is remaining on each of the axles, and those will be expressed as a percentage. On the right-hand side, we have views, including bridge view, center of gravity view, and turning radius view. We can get into those later. And up top, we can generate a PDF report and save or share this calculation. But let's add a body first. So I'm just going to add a service body. And there is a library of body specs here. You can search that existing library, or you can choose to import a DXF file. So before we move forward with importing a DXF file, I'm just going to hop to the Reading website here, where I can find some very basic drawings for these 132-inch service bodies. And we're going to use the drawing for this space maker. So you've got the very simple drawing here below and some high-level weights and dimensions up above. So I'll go back to the TruckScience interface now. And I'm going to import a DXF file. So I have used an explainer video on our website to prepare a DXF file for import. And this is it. So I'm importing it. I just need to specify its length as per the Reading website of 132 inches. The height from the top of the chassis to the bottom of the body, we'll leave that at 10 inches. And the width, I think, is 93. Yes. So I've just taken all of these values from the information on the Reading website. 21.5 inch compartment depth. Again, the body weight is on the website. You'll see it here at 1,620 pounds. And the center of gravity information is estimated by default, but you can override it here. I'm just going to give this body a description. And add it to my drawing. I can drag the body to move it around to create a cab gap. Or if I open the body, I can specify the position by typing it in, and we're going to move it 2 inches from the cab. Now that we've added a body, a maximum payload of 5,109 pounds has been added here. And as I mentioned earlier, that has been calculated based on the permissible weight, the comparison of the total unladen weight with the permissible weight. So we are achieving a utilization of this vehicle's total capacity of 100%. In some cases, the front axle or the rear axle may max out before the total vehicle capacity, and we might see that later too. Now that the body has been imported, we can also maybe just quickly have a look at some of these other views. So we can see the overall vertical center of gravity at this point is 35.9. And the smallest turning radius for this vehicle is 355 inches wall to wall, which is about 29.5 foot, or 334 inches curb to curb, which is at about 28 feet. So we just go back to the side view. So at this point, I can choose to save this body to my library. I can save it to my personal library, so it's available to just myself in the future. I can choose to add it to my team library, so it'll be available to my colleagues on the same subscription or account at TruckScience. Or if I am the manufacturer of this body and I wanted to share it to all TruckScience users, I can choose to share it to the public library. And lastly, if I want to share it outside of my own organization, but only to trusted or approved distributors, I would choose to share it to the distributor library. We'll get into those in a little more detail, or at least talk about those levels of sharing again in a little while. Let's add some equipment. So we've already dealt with the chassis here, so the body, and now we can add some equipment. I'm going to start with a crane. And as you can see, there are a lot of cranes that are already in the library here. Again, you can use the filters to narrow them down. Or again, you can choose to import a DXF drawing. In this case, I'm going to import a DXF drawing. And this DXF drawing I have found through the Auto Crane website. So I just went to Products, Service Cranes, this 16-foot EHC4, and under the resources section here, you'll find the manual or the spec sheet with drawings, dimensions, center of gravity, and weight information. So if I could just pop down here. can find some dimensions information, or further through the document, there are some drawings which we can trace. Just pop back to TruckScience again. So we follow the same steps as for the service body, but we're first going to just position the mounting point onto the x-axis. So they'll be reflected correctly on our drawing. Specify the length here at 113.9, which I found on that spec sheet. The width was 21.4. And the weight, I think, was 960 pounds. For the center of gravity, we can switch to inches rather than percent, as that was what was indicated on that spec sheet, and just fill in the various center of gravity values here. Lastly, I want to name the crane. And add it to my drawing. So to position this crane, we can simply drag it, or I can open the crane over here, go to the position tab, and specify its height above the chassis, which you're going to set at 30, and we'll move it 5 inches from the back of the cab. You may have noticed that our payload has dropped to 4,149 pounds because of the addition of this crane. The crane is taking up 960 pounds of the overall capacity. Again, we could choose to save that crane in my personal library for reuse by myself in future, in my team library for reuse by colleagues, or if I'm the manufacturer of the crane, I can request that it is shared to distributor or distributor library for controlled access, or the public library for access by all users. Lastly, we'll just add one other item of equipment, and this time I'm going to just choose something from the library so I don't have to go through the process of importing it. I'm just going to look for a VMAC multifunction power system. And once more, I can drag this or use the position tab to specify where I want it to lie. Again, this has reduced payload because of the weight of this item. To position both the crane and the power system laterally, I can switch here to top view and simply drag them across. So just to review payload and utilization again, we've now got a payload of 3,649 pounds, and we're still at 100% utilization of the available weight. You'll see that our organization standard that I had set at I needed between 10 and 50% of the gross weight on the front of the vehicle. That is now the case because we have 36.9% of the gross weight on the front. I had also added that favored measurement of the utilization of the gross vehicle weight as a percentage of the total permissible. And as we have in the bottom right of the table there, it's at 100%. So your configuration is being checked with up to 5 states or provinces at once. In this case, we have set it to Illinois state roads. As you go through your calculation and make changes, it will continue to be validated against the state you're in. So let's for instance, switch this energy source from diesel to biodiesel, and nothing has changed here in terms of the permissible weights, still at 5,600, 10,300, and 14,000. But if I switch from Illinois to Colorado, I'm just being informed here that the biodiesel powered vehicles qualify for a 2,000 pound weight increase in Colorado. So you will get some prompts there on some good news. Okay, lastly, I'm just going to generate a report. And I can include or exclude the views that we saw on the right-hand side in this report. So for instance, this one is just the weight summary. Got a center of gravity view, and I can pin those points on there. The top view, the turning radius, detailed breakdown of weights and dimensions, and some further notes and warnings. Paul, this might be, that's kind of it for the demo. If there are any questions, I can take them now, and then I'll just go back to the PowerPoint.
Yeah, sure. There have been a couple of questions coming through. One person is adding if you could add a snowplow to the vehicle, and I suppose that's something that we could do really quickly.
Yes.
So sure, you definitely can add a snowplow. So I think Sor could add that. Um,
This is a Henderson snowplow that happens to be in the library. As you can see, the front axle is now overloaded. It's the permissible weight of the front axle is 5,600, and this heavy snowplow, which is weighing 3,400 pounds, I believe, has pushed the front axle up to 9,178, and as you can see, that is overusing the front axle by 64%. There are some tricks, I guess, to balancing a vehicle. If you were to add some weight on the rear of the vehicle, you may well solve that problem, but I suspect then you're just going to exceed the total vehicle weight. You can see that the total gross at this point is 13,251, and the total permissible weight is 14,000 pounds. But you may also notice that the payload has been zeroed because there's no longer any payload capacity on this vehicle. This is an ideal time to add the "do not try this at home" warning.
Then there's another question about how the weight of the crane, for instance, affects the balance of the vehicle from right to left.
Okay, so if we maybe switch to the top view for a moment, we have the weight of that crane on the right-hand side, and the total weight of the crane is 960 pounds. The total weight of the power system is 500, so I suppose they are helping to balance each other out. But if we go to the center of gravity view, we can pin these center of gravity points just out of interest, and this overall center of gravity is shown from the center point of the vehicle. It is assuming an evenly distributed payload, or simple, what we call a simple payload. I can quickly switch that from simple to detailed, and we have about 3,649 pounds to be exact to play with here. So if we switch to detailed payload, we can start to add other payload items. For instance, I have saved this box of tools in my personal library, and that box of tools, I said, weighed 2,000 pounds, quite a heavy box of tools. You'll see it's currently overloading the front axle just by 2%. So if I were to move it towards the rear, you can see that very quickly that 2% problem is fixed, goes to green. And if I just maybe exaggerate the weight of these tools, weight, and maybe just say that that item weighs 3,500 pounds, you'll see now that the overall center of gravity has moved from the center line to 6.9 or 7 inches from the center line because of those tools. So if I move the tools towards the center, the overall center of gravity should move back towards the center. Yeah, there we go. It's just 0.6 inches from the center line. And again, further underneath that crane, maybe. And now the center of gravity is 8.8 inches from the center line of the vehicle. I hope that answers the question.
Yeah, I think so. The gentleman here also is asking to move the crane back on the vehicle, but but you can move those you can move those items backwards and forwards and place them anywhere really theoretically on the vehicle there and watch what impact that has on the center of gravity.
Yeah, so I just moved that crane maybe ever so slightly back. You'll see that as I'm moving it in the weights table below, the distribution of the weight of the crane, which is the fourth item in the table, it's currently putting a weight of -1 on the front. You can see it's -18 now. So as it moves back, it's obviously taking weight off the front axle, which may have been a contributing factor to a solution to our snowplow. It's at -74 on the front now, and it's actually putting a weight of 1,034 on the rear, despite the fact that it itself only weighs 960 pounds.
Okay,
Any other
great.
questions on this, Paul?
Yeah, there's a question about taking a look at the maximum permissible lateral center of gravity and like taking a look at like what are those maximum and minimums of the center of gravity that you're showing here.
Okay. So firstly, the software calculates the center of gravity three-dimensionally, the horizontal, lateral, and vertical. However, it doesn't yet compare that to an envelope that has been specified by the vehicle manufacturer, in this case, Ford. And it also doesn't yet calculate the four-corner weight distribution. So it's currently doing front to rear. Sorry, it is calculating the four corners, but it isn't displaying the four corners. So it's displaying the front and rear weights, and it is obviously calculating the lateral center of gravity based on those four corners, but we're not yet displaying the four corner weights. So I guess this is an ideal opportunity to talk about our development. So we have a team of developers who are constantly adding new features to the software in response to user feedback. And every time we hear about a feature, we add that vote to the feature. It bubbles towards the top of the list and will get developed as a result. So for instance, after this webinar, we will give that feature another vote. The comparison of the lateral center of gravity, or indeed the vertical center of gravity, with the OEM or chassis manufacturer's suggestion, I guess, or what is permitted. And then also that ability to view the four corner weights as opposed to just front and rear and the lateral center of gravity point.
Great. There is one other question here that we haven't really gotten to, and that's about whether it's possible to add a pusher axle to larger vehicles.
Yes.
And so I mentioned to the gentleman asking that question, I believe, that it is possible to add pusher or tag axles to a vehicle to be able to spread that load across.
And I can quickly do that just to demonstrate what that looks like. It'll be very quick. So I just choose a more suitable vehicle for a start. And I think the favorite 6x4 that comes up in a lot of my demos anyway is the T880. So I'll just grab one of these. Not sure what I normally ask who's ever in my demo to help me choose one. So So this one happens to be missing front and rear weights. Oh, and sorry, I didn't choose a 6x4. Let me get back out there. So I can sort this or filter this list on 6x4s only. And for instance, I can do the Kenworth T880. Let's grab one of these. Okay, so maybe we can just add a template dump body for demonstration. Obviously move that along. We've currently got, in the state of Colorado, we are achieving a maximum payload for this particular setup of 20,833 pounds. And this is actually, previously when we were looking at the Ford vehicle, the total gross vehicle weight rating or regulation limit was the limiting factor. In this case, because the 100% utilization is on the front axle, we still have unused capacity there on the rear axle of almost 1,000 pounds. It's at 918, but the front axle is maxed out. We can, however, try adding a pusher axle. We can do that from the chassis menu, weights and axles, add pusher. And the payload has jumped from 20,000, I think it was, odd, to 30,734. If you want to, you can still see the center of gravity and the turning radius and all of that. Does that answer that? And we can change the tire sizes here. The tire radius, the tire width. I think the tire width has an effect on the maximum achievable weight on this axle in some states anyway. So if I just experiment with this live on air, I'm going to increase the tire width and see, does that do anything for our payload?
I think you might be limited by the manufacturer's specified weight for that pusher axle there.
Okay. The gross axle weight rating of 13. Do I push that up to about what, Paul? Help me out.
Oh, you can push it up to 20, I suppose, but I think that in this case, you're not going to be limited by the tire weight, it looks like.
Okay.
It's not going to have an impact there.
Okay, in this case now, the tandem axle is maxed out at 100. So I guess that just illustrates the point that every change you're making, the software is doing the thinking in the background, applying the manufacturer's limits and the road regulations, or state road regulations in this case, and calculating the maximum achievable payload.
I have another question about like different payloads that we can put on a truck like this, and whether you can put a payload of pallets with different weights and different center of gravities on the truck. And just to mention that, yes, you can add in multiple detailed payloads and add different weights and center of gravities on each of those.
Okay. What I'm going to do, I'm just going to maybe flip back to the presentation for those that are interested in the distributor library, and then come back to the live calculation and work on that. So
Sure.
just before we go, I just want to make a note of that one, and that was to specify pallets with different center of gravities, different weights. Is that fair enough? Are there any other questions that you would like me to answer right now?
I think we can go through them and answer them after you wrap up that part. There are a few more.
Okay, you should hopefully be able to see my my PowerPoint now.
Yeah.
So during that demo, I demonstrated how product specs for chassis, bodies, equipment, and payload can be saved to our library. And this is, I guess, one of the most popular features of the tool. But I also mentioned that access can be controlled. So if we just take a quick look at this graphic, by default, when I save a product spec, it is saved to my own personal library and only reusable by myself in the future. Secondly, if I save it to my team library, it can be shared among users on my own account or within my own organization. We just skip one down to public, and this is the least locked down option. All users of TruckScience within your market can add this product to a layout. And then the the level between team and public is, we call it a distributor library, and you can choose to promote your products to users who are outside of your organization as long as they have been authorized by you. So crucially, the distributor library is locked down to whoever you have granted access to. So we'll just keep going quickly, and then we'll come back to more of a live demo at the end. But as a manufacturer, you may be wondering why you should add your products to the library. Many manufacturers have been adding their products in response to requests from upfitters. Others approach us to add their products when they see it as an opportunity to promote their brand. And manufacturers who want to control the quality and accuracy of information that's out there about their products also choose to add the products to the public library. Sharing your products allows you to define accurate weights, center of gravity, and dimensions. Sorry, if you just choose or compare the two graphics at the bottom of this slide, you can see that the quality of the drawings is not really comparable. On the left-hand side, we are using a template chassis with a template crane, and on the right-hand side, we're using a genuine Kenworth drawing with an original drawing from Hiab. So sharing your products allows you to define the accurate weights, center of gravity, and dimensions, and also allows your products to be represented with more professional, true-to-life drawings on our reports. In some cases, there is most certainly and naturally a concern that adding products to the library will put information in the public domain that manufacturers would prefer to keep closer to their chests. However, others tell us that in this information age, it's impossible to keep this kind of high-level information secret. We hear tales of drawings being exported from other tools, shared on the grapevine, or obtained through practices such as mystery shopping. Certainly, adding your products to the TruckScience library permits users unknown to you to have access to a basic sketch and high-level weight and dimensions information. If this is a concern, we always recommend that you start with the distributor library so that you can control who has access to the information, and then later maybe consider promoting your products to the public library. What is the alternative to adding your products? We've spoken to some users or in the industry who've expressed frustration at some manufacturers' unwillingness to share product specs to the library. And these are some of the alternative avenues that I have seen these users take. In some cases, products are being represented as rectangles alongside other professional drawings. So if I just quickly show you what that looks like, if we add, I'm sorry, I have to switch back to my other screen here for a moment. Going to add this other equipment template, and we've got a rectangular box as opposed to a nice drawing of your product on the drawing. Upfitters sometimes choose a competitor product for which there is a spec available. So if there's a competitor who has their product specs in the library, that may just represent a path of less resistance and could result in that competitor product being chosen. And sometimes they'll use a competitor product to misrepresent yours on the drawing. So just use an alternative drawing that isn't true to life at all, of course. And we have also heard anecdotally of product drawings being exported from other tools out there. It isn't possible to reverse engineer or export a drawing from TruckScience. So the only thing you can take from TruckScience is the report that I showed you. And it is impossible to get any information from the drawings in these reports. They are static, a handful of lines, and there's nothing further to be shared, to be taken from those drawings. There is limited data in the public domain anyway when they're added to TruckScience. As I said, it's a very simple sketch drawing, and there's no DXF file available to be downloaded or reverse engineered. There are very few attributes that are provided, just simple weight, center of gravity, and major dimensions. And most of that information, or at least a lot of it, it's already available on manufacturer websites or can be measured off the physical product. You've seen this already. You'll have seen when I imported the drawings, there were no CAD drawings. There are no CAD drawings saved in the TruckScience program. Even if we help you to add products from your CAD drawings, the CAD drawings are not uploaded to the platform, so they're not available. Just a very simplistic general arrangement drawing like you see here. So if you're a fleet engineer or an upfitter and you're wondering where to start with this, you can reach out to your body and equipment manufacturers or ask us to do so on your behalf. And if you're a manufacturer, we'd encourage you to identify one or more products, work with our data team to add that product, and then just build on that and decide who should have access to them over time. It's definitely easier to just start with one or two products and test the water with those. You can also at that point identify one or two dealers who you would like to set up in a distributor library and just see how that whole process works. Of course, you can consider widening the audience later. If you'd like to set up a personalized demo for yourself or colleagues who weren't able to attend today, or some time to discuss adding your products or to discuss this whole process of adding products and how that might work if you're an upfitter, I will be more than happy to meet with you. So you can access my calendar by just accessing that QR code on your mobile phone camera. I'll just give you a couple of moments to do that in case anyone would like to do that. And then I'll just talk about a little bit about where to find out more about TruckScience, and we're obviously just going to jump back to the demo then, because I am conscious of time. So if you'd like to find out more about TruckScience, you can take a look at our page on NTA's website, nta.com/TruckScience. You can take a look at our own website, truckscience.com. And very happy to tell you that we have confirmed our attendance. We'll be exhibiting at the Water and Wastewater Equipment Treatment and Transport Show in Indy in February. We'll be back in Indy in our usual spot on the NTA Partners booth at Work Truck Week in March. We'll be at Waste Expo in Las Vegas in May. And we will be at Utility Expo in Louisville, Kentucky in October. Those we are confirmed to be visiting all of those shows already, or at least exhibiting at them. And we obviously also hope to see you all back at the 2025 Commercial Vehicle Upfitting Summit when that is scheduled, date to be finalized, I believe. In the meantime, if you're not already using TruckScience, please help yourself to a free trial from our homepage, truckscience.com. Members who add their membership details will have their trial automatically extended from 7 to 30 days and will also qualify for a discount on checkout. I have some information about pricing, which just in case anyone needs it, but I won't go into that for now. I'm going to go back to the live calculation to get those pallets on there. So just a moment. I'll just go back to this live calculation. Take off that piece of other equipment. I'm going to take off this body, just cut it with the scissors. I'm going to add a flatbed. And then I will switch my, just a moment. Just going to reduce the headboard down to 0 there. I'm going to switch the payload from simple or evenly distributed load, which before I do that is at 37,389 pounds maximum. Going to change that to what we call a detailed payload and add some items. So we can add some payload that has been already added to our public library. And this is just to prevent lots of rework, I suppose, people having to import the same things. So for instance, there's a skid steer. You might want to see it the other way around. So the payload is the weight of that, 3,968. You can also add some pallets. Brick standard, let me see, pallet load block stacking. Let's see what this is. So you can have various payload items. This is obviously very non-standard setup here. Bear with me. Let's go to the public library for some sample GMA palette here. Obviously, we can move things around here in the top view. Well, it's quite a big one. We may need to extend the wheelbase here, get a bit more space. Then the body length, say to 290. And then we can move this piece of payload here. So obviously those pieces of payload can have different center of gravity, different weights. This is the pallet load block stacking, whatever that is. The weight is 1,764 and the center of gravity is defaulted to the very center of that. But for instance, we could reduce the lateral center of gravity to just maybe, sorry, the vertical to 30% of the weight, and maybe load it further towards the front as well. You can most certainly manipulate the center of gravity and you can specify it in inches or as a percentage. Does that answer that question, Paul?
I think so. Yeah, I think that was a nice explanation. You can also, yeah, that's great. I guess do we have time for a couple more, sort of?
Yes. Yeah, I mean, I have time if I hope others do.
Okay. Then there were a few questions about whether we have like electric vehicles in the database and lowboy trailers and things like this. So maybe if you could, and you mentioned some of the ways that we can get more manufacturer vehicles in there and things. So maybe if you could just take a look at that or address that.
Okay. So this is a Mack Electric LRE. The front and rear weights are missing from this one. So in this case, you just get them from the dealer, I guess. I think these vehicles are quite weighty. I'm just estimating these just to explain how you would do that. But you would obviously need to get those weights from the chassis manufacturer, and this one is also raising that point that the battery-powered vehicles qualify for a 2,000 pounds weight increase on Colorado state roads. So that's the electric vehicle. You asked about trailers.
We have any lowboy trailers? I don't remember off the top of my head if we do, but I think I've seen some there.
Yes, and they can be, so I need to add a fifth wheel. They can certainly be added anyway on request.
Yeah, for sure.
I'm conscious that I'm doing some very non-standard stuff here, but
oh, this will be a nice setup.
This one maybe.
Oh yeah.
Something like that. It's looks like we've got some compliance issues here.
Well, likely so. Nice float trailer on that garbage truck.
Any other questions, Paul?
Yeah, we do have one that actually I might actually even kind of paraphrase it out loud because it's a great question. And I think when you were doing that 6x4 earlier and adding the different components to it, then one gentleman asked whether you can essentially simulate a truck under a full load and move any added lift axles around to get the best layout before actually installing all the parts. And I think that sums up the tool very nicely. That's exactly what you can do. You can simulate those loads as they are on the vehicles and try it out and see what happens before you actually install everything.
So I guess in this case, if we just add that flatbed again. And we've got a maximum payload of 37,389. I presume, Paul, if I maybe increase this bogie spacing, yeah, the payload is changing as we increase the spacing between those axles. if I switch back to Illinois state regulations, you know, things may be different. And I suppose that's the power of the tool, is that you can test out up to 5 states at once, make changes to your configuration, and review the bridge groups. You can see the maximum bridge, the unused bridge, and the utilization of the bridge. So you'll see that with this payload of 33,411 pounds, the rear group 2 to 4 is at 100% utilization of the bridge.
Mhm.
I should probably maybe pop up the slide again where you can if anyone would like to schedule a personalized demo. And if are there any other questions, Paul, or should we wrap up there?
One, I guess, very last question that I could just mention was that somebody asked about the sources of all the regulations, like what database we get the regulations from, and we actually we read all of those legal texts and interpret those regulations into those regulations that are seen in the program. So that's done on like a very manual basis on a state by state and province by province in Canada basis. Yeah,
Okay.
and that's all the questions, I think. Yeah.
Thank you, Paul. And thank you for all your questions. It certainly makes the webinar more engaging if you know, you're sharing your thoughts and questions as we go through. So we've gone a little bit over time. Thanks for that engagement. That's pretty much it for today. I'm just going to end this webinar now in a moment. And before you go, if you'd like to please rate the webinar, leave any comments or questions. And if you'd like to get in touch after the webinar, just leave a comment and we can reach out to you. Otherwise, of course, you can schedule a demo straight away here. But yes, thanks very much for joining us today, and goodbye.